Hey everybody, so today I'm going to be going over the key features and characteristics of graphs. So we've got this beautiful graph in front of us and we're going to find everything. Domain, range, increasing, decreasing, constant intervals, and I'm also going to explain what those are because that's probably the most important part of this. Okay, so let's start with the absolute basics. Let's start with domain. What is the domain of our function? Okay, well, let's take a look. The domain is the set of inputs that we have, or our x values that we use on a graph. So if I'm looking on my graph here, I have a starting point right here at 0, okay, on the x-axis. Now, the last value I see on the x-axis is 16. So my domain, if I want to actually write this down, my domain is going to be from 0 to 16, okay? Because those values, every value in between 0 and 16, and including 0 and 16, those are a part of my function. That is my domain. Those are all my inputs, okay? Now, let's go over range. If domain is the set of all inputs, then the range is going to be the set of all outputs. So, what are the outputs of the function, basically? So, if I look on my graph here, my lowest y value, okay, we're looking at our y values now. Our lowest y value is at 0. Which means my highest y value must be whatever that one is. That lies right in here. It's between 8 and 10, perfectly in between, so I'm going to assume it's 9. Okay? Because it's going up by, halves. Not 1, but halves. So, if I were to write my range out, I'm going from 0 to 9. Sorry, it's very, very tight because I don't have a lot of space there, okay? Why is it from 0 to 9? Because the outputs that I get on my function, if I'm going to trace my function, I am going from 0 to 9 in my output values, okay? So now that I've gone over domain and range, let me go over max and min, because that's something else that we're going to have to focus on. Well, our maximum is our highest point on our function, okay? It is the coordinate point that is at the highest peak of the given function. So if my given function has a highest point at 1725, then 1725 is my maximum. Looking on my graph here, though, if I go over to 7 and then up to 9, I reach my maximum. So my max is at 7, 9. We're going to write that as a coordinate point and not an interval. Same thing with our minimum. Now, here's the key to max and min. We never use the endpoints. So I'm going to look for the absolute lowest point on my graph here. Well, if I'm not counting my endpoints at 0 and 16, then 10 is where my lowest point is. So my minimum is going to be at 10. What's a 10? I promise. 10, 0. Just a couple more things really, really fast, okay? I want to focus on where my graph is increasing. What the heck does that mean? Well, when you increase something, you get more of it. When you increase the value of your house, the price gets bigger and bigger and bigger. It's the same thing on a graph. When you're increasing on a graph, your y values will start to get bigger and more positive as you go along the x-axis. So where on my graph do I see my y values becoming more positive? Well, let's figure that out. If I start at 0, and I keep going, keep going, keep going, I can stop right there at 3. That is one of my increasing intervals. Okay, so I'm going to increase from 0 to 3. Is that the only spot where I'm increasing? No, it's not. I've got a couple of places where I'm increasing, okay? From 3 to 4, nothing's really happening. But from 4 to 7, and you'll notice I'm using the x values and not the y values because we always use the x. But from 4 to 7, I am increasing in value. So I use this fancy little symbol here. I'm not going to make you do that, but that just means and. So from 4 to 7, I am also increasing. There's one other spot that I'm increasing, and I start here at 10, and I keep going until I get to 12. So I've got a third interval where I am increasing. If increasing is where my y values are getting bigger and more positive, then decreasing is going to be where my y values get more negative, or they get smaller, okay? Sometimes it's not negative, but they do definitely get smaller, okay? So think of it as you decrease the number of calories you eat. Instead of eating 2,000, you eat 1,200 or 1,500, okay? You decrease the pressure in certain objects so that they don't explode. So where on my graph am I decreasing? Well, all the orange parts are where I'm increasing, so I'm looking for where my y values start to get smaller. Well, at 7 to 10, those y values definitely get smaller. So one of my decreasing intervals is from 7 to 10. Unfortunately, that's not my only one. I have another one over here. It looks like that's at 13 because it's landing between 12 and 14 on the x-axis. So 13 to 16. So from 13 to 16, we are decreasing. One other type of interval, really fast. Okay, last but not least, we have our constant intervals. These are the intervals where nothing's really happening. Okay, so from 3 to 4, nothing is happening. Okay, there is no change up, no change down. It's just neutral. It's like this nice straight plane line. So we call those constant intervals. Okay, so one of my constant intervals is from 3 to 4. Once again, a reminder, we're using the x values, no y values for these intervals. We've got one other constant interval, and that constant interval is from 12 to 13. Okay, so from 12 to 13 is where we have our second constant interval. Very quickly, we do have a y-intercept. I didn't go over this, but we do have a y-intercept, and I do want to point that out super fast. 1 second. And that y-intercept is the point on the y-axis where, we cross it or touch it. 0, 0, it would be the y-intercept. And then for our x-intercepts, the points where we touch the x-axis, those happen to be 0, 0, 10, 0, and 16, 0. I'm not going to write those down because those aren't the most important things. But hopefully this helps you know how to find domain, range, max, min, and all the intervals that you need to find. Good luck with everything, guys.